evaluate this triple integral where E is the solid that lies between the cylinders. So it mentions cylinders, so we are using cylindrical coordinates. X square plus y square equals 1. So this is r square equals 1, so pretty much r equals 1. And here same thing, r square equals 4, so r equals 2. We are just considering positive r values. Above the xy plane, that means g part is 0, okay, above, and below this plane, g equals 4 minus x minus y. And when we are converting into cylindrical coordinates, this becomes, let me write here because we need later, 4 minus x is r cosine theta minus y is r sine theta. Okay, so this triple integral we can always write into double integral, then g coordinate dg, and the function is just x. Okay, so let me write x for now, and this double integral in terms of this area, and g above xy plane, so g equals 0 to here. For now let me write 4 minus x minus y. Okay, now we need to find this domain, this region D, that will be the projection of the given solid E, by the way, projection of E into the xy plane, and we convert this into r dr d theta. So if we look at closely here, the solid lies between the cylinders, this and this. So if we graph in R2, that's in 2D, x square plus y square equals 1, that's r equals 1, and there is 4. Okay, so basically we are looking at this region between these two circles. In xy plane, these cylinders are circles. Okay, so outside is 4, inside is just 1. Oh, this 4 means 2. 4 means 2 is squared, so this is 2. So in the next step, now we're gonna write this in terms of dA is r dr d theta, as we've done in double integrals earlier. Inside we have g equals 0 through 4 minus x is, look at here, we have done earlier, 4 minus r cosine minus r sine, r cosine minus r sine theta. The integrand is x is r cosine theta, by the way, and outside now first r then theta. So we are going around a circle, so all 360, 0 to 2 pi, and r inside is, inner is 1 and outer is 2, so 1 to 2. Okay, and now we can evaluate this easily. That's the whole purpose. Okay, so I forgot this dg part here. So here is dg, r times r will be r squared. Okay, so let's do this. Outside theta equals 0 through 2 pi, and then r from 1 through 2, r squared, that is independent of g, so we can pull outside here, and cosine theta is also independent of g, so cosine theta here too, r squared cosine theta, that leaves 1. Antiderivative of 1 with respect to g is just g, and we have upper bound, lower bound. So 0, upper bound is 4 minus r cosine minus r sine, and we have outside dr d theta. So theta from 0 to 2 pi, r from 1 to 2, and upper limit minus lower limit, g equals this whole chunk minus 0, just that. So we have r squared cosine theta times 4 minus r cosine theta minus r sine theta, and we have dr d theta. Now we need to integrate this, got a bunch of things here with respect to r, so this theta will be just constant, so it should not be that bad. But first let's distribute, okay, at least r squared in 3 terms. Okay, so that means theta equals 0 through 2 pi. This is r squared 4. Cosine theta is independent of r, so cosine theta we can pull outside here, so we have to take care of this at the end. And from r from 1 to 2, r squared 4r squared minus r cubed cosine theta minus r cubed sine theta, and we'll integrate this with respect to r, then later with respect to theta. So here theta from 0 to 2 pi, and we have cosine theta here. Antiderivative of 4r squared, that's 4r3 over 3 minus cosine theta is constant for r cube, this is r4 over 4 cosine, similarly r4 over 4 sine theta, and we will be evaluating from 1 to 2. And d theta, dr is taken care of here. Now theta from 0 to 2 pi, we have cosine theta. Let's evaluate this upper limit. So this is r, so r equals 2, plug in 2 throughout, minus then plug in 1. Okay, so replace r throughout by 2, so we get this, and replace r throughout by 1, so we get this. Now we can subtract here. So cosine theta outside, 4 copies of 8/3 minus 4 copies of 1/3, so 4 copies of 7/3. Similarly, we can combine this minus this, so we get negative 15 over 4 cosine, and similar this. Now we have to integrate with respect to theta, so we need to distribute here. Okay, and let me write what we get here. So we have theta from 0 to 2 pi, this is 28/3 cosine theta minus 15 over 4 cosine square theta minus this is 15 over 4 cosine theta sine theta, or sine theta cosine theta. Okay, and we need to integrate. Cosine square we cannot integrate as it is, so cosine square theta is same as 1 plus cosine 2 theta over 2, then we can integrate. For sine cosine, sine theta cosine theta, we can multiply by 2 and divide by 2, that makes 1/2 times 2 sine cosine is in fact sine 2 theta double angle, then we can integrate easily. Or you can use substitution or integration by parts. Okay, so let me write this over here. So we get this, okay, 1 plus cosine theta over 2 I'm writing here, and I divided by 2 and multiplied by 2, so divided by 2 means 8, and 2 sine theta cosine theta sine 2 theta. Now we are ready to integrate, so let me do over here. Antiderivative of cosine is sine, so this is 28 over 3 sine theta minus 15 over 8, inside antiderivative of 1 is theta, plus antiderivative of cosine is sine, minus 15 over 8, antiderivative of sine is negative cosine 2 theta over 2, and we need to evaluate from 0 to 2 pi for theta. Okay, so let me plug in theta for 2 pi for theta. Sine 2 pi, that's 0. Sine 2 times 2 pi, that's 0 as well. But cosine 2 times 2 pi, that's 4 pi. Cosine 4 pi is 1. Okay, I'm talking about upper limit. And lower limit 0 makes sine 0 0, sine 0 0. So these first two things are gone. And here upper limit 2 pi. So let me start writing. Upper limit makes 0. Here is negative 15 over 8. Here is 2 pi. This part is gone, but 2 pi times 2 pi minus 15 over 8. This negative, negative, positive 15 over 8 cosine 4 pi. Okay, 2 times 2 pi. Cosine 4 pi is same as cosine 0, which is 1. So 1/2. That's from upper limit. Minus lower limit 0 makes sine 0 0. This is 0. theta 0, so everything's gone, minus minus plus, so 15 over 8 times cosine 0 is 1 over 2. Okay, this negative is coming from fundamental theorem of calculus. Cosine 0 is 1, so 1/2. Okay, which is, this is negative 2 goes 4 times 15 over 4 pi. Here is 15 over 8 1/2 minus 15 over 8 1/2. So these two cancel, positive negative, so this is it, final